Oh yeah. Thank you, Mickey. So fully defining sketches is a concept that I kind of want to review a little bit more in depth with all of you, because there was a lot of questions on that, and kind of what that means. And the other bit was that people were getting caught up with was just the mechanics, like, you know, what does right clicking do? What does left clicking do? Do you have to double click on, you know, certain things? So my hope is to review a little bit of that. So, you know, we can't cover all of it all in one sitting, but we'll cover some of those things at the kind of the first half of this. All right. Are there any, like, just, I would say, general overarching questions or like other things that you'd like to see, I guess, covered in this session?
I have a question. Are you planning on doing the videos for all of the homework packets?
Yes, I am. I've had pretty positive feedback from that, because I'm able to put little details in that aren't found in the PDFs, like mechanics, you know, how things click and whatnot. So that seems like it's been working well, but what do you think?
I mean, it seems like a lot of work on you, but I love it.
Okay. Yeah, I have to go through the tutorials anyway. And so it's pretty much just like a stream of consciousness coming out of my mouth as I'm doing the tutorial. So it's no big deal on my end. Thanks.
I have a question. Do you already have all the tutorials from the start to finish already laid out? I mean, do you already have our homework already to the end, right? To the end of the class?
That's a great question. So there are 9 lessons total. So really, if you guys are up through like mid lesson 4, and lesson 4 is huge. All right, lesson 4 is by far the biggest, most time consuming of them all. And that's partially because sketches are like the foundation of CAD. So I would say halfway done. If you're up through 4, you're halfway done. After lesson 4 and kind of the second half of this course is going to be practicing. And then I've put together like I'm 80% put together a challenge for all of you guys. So it'll be kind of a fun competition. You get to share your design, and there will be some prizes involved too. So that'll be kind of the second half is just practicing and building on the skills that you learned in the 9 lessons that we have. Does that help answer?
Yeah, I was thinking what'd be really kind of nice is if we could just get every lesson from, you know, lesson 1 to the end all in one sheet, and then I just pick it off as I go. Because right now I'm struggling because I'm kind of illiterate with a lot of this stuff. But trying to get all the information together, lined up, so that I can just go through step by step. Because I know I'm supposed to be finishing up this last lesson that I didn't quite finish, but I couldn't exactly find where I was, and you know.
Sure, I'm happy to do that. I'm more than happy to, if that seems like a better platform for everyone else.
Well, Brett, that would work for me, because I think I mentioned on Sunday that what I did was I printed out all the PDFs.
Yep.
And I 3-holed them. So I have a notebook here, and that might seem old school, but I guess I am. And it's a way for me to go in order, and also everything's there.
Sure.
You know, not finding the difficulty. One of the difficulties I was having was just going back and forth from screen to screen as I was trying to do the different lessons. Now, I did have one question since we talked on Sunday. And do you happen to know if there's a difference between the user interfaces on a Windows and in a Mac?
I like 100% of my work is done on a Windows, and I've had to learn on a Mac for this class because that's what I'm using. And the design interface is no different. It's the exact same, but the key shortcuts, that's going to be different. Instead of using Control for like Windows, you're going to substitute that on a Mac with the, oh my gosh, and I say it in my tutorials. It's funny, I'm using a Mac with a Windows freaking keyboard. So anyways, there's Control, and then there's what?
It's the command key, Brett. The command key.
All right, so you use command to substitute control on a Mac, but then the interface itself is completely the same.
Okay,
And the mouse
thank
is
you.
the same too. Yeah. All right, Dana, go ahead.
Yeah, I really thought, first of all, I thought the videos were awesome because I was trying not to use the videos and then I would totally get stuck. And then I would be like, okay, I'll go to the video and they would just push me through wherever I got jammed up. When we were doing the planes cutting through the objects, I just didn't really know what those are for. So when you do stuff that's like not intuitive, if you could just say like, I could see using this for this, and then it would open up my brain to it.
Yeah, that's a great point. And on that note, sometimes I don't even like, no, I think like 80% of those plain functions I never use because there's workarounds. You know, there's different ways to like make the same end design or end part. And what you'll probably find too is you get like a powerhouse set of tools that you approach any problem with or any design. And so like, yeah, you go into like the construct plane and there's like 12 different options, and who's going to use a 3-point plane? Yeah, I certainly don't, but I will try to kind of think, you know, as I'm running through that, where and why that function might be used.
Thanks.
Yeah. Yeah, Dan? Uh-oh. You cut out.
I just had a quick question regarding the hotkeys you were talking about. You mentioned possibly sending out a list of shortcuts, and did you already do that, or is that something you're planning on doing?
No, I will, and I'll do that. I'll post that with my follow-up email for this week, and I'll just send you a link to Autodesk's website where they have just a laundry list of those hotkeys. The nice thing about Fusion, which they don't have on all their softwares, is if you like toggle over one of the functions, it'll show in parentheses the hotkey. So if I toggle over extrude, it'll show E. You can press E for that, but I'll give you the list as well. Bill.
Yep. Two questions. One, how do you make the little raised hand thing work on Zoom?
It looks like some other people probably know better than I, so I'll let one of them share.
You can go down
Yeah,
to reactions. At the bottom on the right side, there's a little smiley face and it says reactions, and you can click on that and raise it. And then when you're done, you can click on it again and lower it.
Oh, that does it. Okay, good. That's the first one. The second one was I noticed that thing that you were talking about where as you'd go in and toggle one of the choices, you could get the little hotkey at the end of it. So I just made up a cheat sheet.
Nice.
And I keep it here next to the computer. And it's really interesting. So many of these are so much faster than just clicking something on, like the construction is X. And, you know, that was just so much easier. So anyway, I think it's going to be useful when you get that out for everybody.
Yeah, Bill, you're right. It is a lot faster. Once you kind of get through those nuances and you become literate with the keyboard itself, CAD gets a lot faster. So that's great you picked that up.
Do you want to tell him about the chat function too? Make sure he opens that up.
Yes. So down also at the bottom of your screen, there's a little chat icon and the word chat. And you can, on the right-hand side, the bottom right, type in a message that the group can see. So if I'm, say, for example, monologuing or whatever, showing something, and you have a question, but you don't want to interrupt the stream of conscious, you can type that in, and Mickey will flag me, or I'll check it periodically.
Okay.
Yeah. See, Mason says hi, Bill.
Yeah, I saw.
Mickey, you have
Mason.
You have a question, Mickey, before we get started?
Yeah, I just had a quick technical question. I was having trouble telling it to do the angular dimension versus linear dimension. And, half the time I would guess what I was trying to do, but I couldn't quite figure out how to make it consistently do which one I wanted to. Is there?
Part of that is, yeah, maybe where your angle is at, and especially if the angle's really flat, it won't be as smart as you want it to be. So I believe you can right click and then choose the dimension, the dimension type within the couple of options by right clicking. We can try that here in a second. So if you, for example, I know if you like click on a circle to dimension a circle, you right click and it'll either be, you know, radius or diameter as one of the options. So we'll give that a shot. Cool. Anything else before we dive into it? Yeah, go ahead, Mason.
Hand raise.
Yes.
Hand raise. Hi, Brett. Hey, I had a problem with one of my sketches just deleting randomly. I did not delete my sketch, and the sketch is now deleted. Is that, do you think, a user problem, or perhaps could that potentially be a software issue?
Well, it is cloud-based, so if you have
The
like
one with the slots, the slot one is just gone. Like you started anyway. Okay.
a spotty connection or something, that it's too hard to tell without looking at it, Mason. But I either we can recover it or we can remake it. I can work with you at work maybe tomorrow and see if we can.
Okay. Okay. Thank you.
Alrighty, so let me screen share real quick. Well, I'll give you kind of a preface for the day. I'd like to do a little bit of review up to where we all kind of currently are, and I know that's kind of a broad range, but I think everyone's around like midway lesson 4, maybe, or I'll at least stop the review there. And I would like to touch on a few things, like editable documents. I don't know, maybe you guys have run into this issue yet or not, but we'll cover that. And then I want to go over an example, which should also be review, but you'll hopefully be learning some things of fully defining a sketch. Okay. After we do that, we can do a little bit of Q&A, and then the remaining time can be, you know, work time to keep chugging along. And unless I have any, unless I hear any reservations to it, I'll plan to send out the rest of the coursework all at once. So you guys will have, after today, you'll have all of the lessons 1 through 9 to chip away at, if that seems good. All right. Screen share. Oh, I also have a few small presentations that I want to share. And I think that actually might be the best place to start. Excuse me while I find it. I don't know where I put it. Give me 1 second. Yeah, I think this will be a better place to start than jumping right into. Okay. So kind of picking up off the presentation from last week, I didn't go through this, but I'd like to now. And that is the CAD workflow. And I think understanding this will help us understand at least the steps and the process that we're working on in CAD. So just looking at this generally, moving from left to right, you're going to start with an idea or a concept in your head. And then you're going to move from that into these various stages to where you'll eventually end up with a part, you know, physically in your hand, ready to operate or to function. If we look at a little closer at concept, this is free form. All right, it's unconstrained, and it's just a general idea. Unconstrained means that you haven't necessarily put dimensions to it yet. You haven't put measured angles. And so the concept at this point, or the design, is pretty flexible. All right, you can shift it to accommodate maybe its end function or something like that. From that point, the next step is, once you have a fully developed concept, you moved into designing it in CAD. And that's what you guys have been working on this week. So this is where you apply size, dimensions. You define it, like you literally narrow it down to a very focused and defined shape, and it's fully constrained. And what that means is it's a rigid design. There's not a lot of you're making a decision on its form and its function. The way you do this is through a series of 2-dimensional sketches, okay, in 3-dimensional space. Dana, you were mentioning making planes in a bunch of different ways. And so that's how you create 2D sketches in 3D space, is you define those planes. If it's not if it's not one of your origin planes, you're defining it yourself. From those 2D sketches, you use a variety of extrude tools to add depth to your profiles. So I think this is a pretty great example. We haven't seen. Hello? Someone say something or have a question? No? I think this is just a great example that kind of illustrates this concept here. Or these concepts, and that is we've created a sketch or a profile which looks kind of like a rectangle with a hemisphere on top of it, or a semicircle. And once it's fully defined, it has then been revolved, which is an extrude tool, around the center axis. Okay, so it's revolving around at this radius here. So the power in this is that you can build and model extremely complex geometries. This turbine engine here, I mean, it's got literally thousands of components, and you can model this turbine or this engine down to the last nut and bolt. And that's all built off of just a series of 2-dimensional sketches, right? And then profiled into the 3rd dimension in a variety of different ways. All right, so you've come up with this concept in your head. Maybe you've sketched it out, or maybe it's just in your head. Then you've gone and you've physically built it in CAD, but it's not quite ready to manufacture yet. You first have to analyze it. In the analysis, you're going to consider a few different things. You're going to analyze how it's assembled. So if you take this engine, for example, it's not trivial how it all has to come together. And maybe you have to redesign so that it does come together in the order, or the set of steps that you've made for assembling it. You can also do things like stress analysis. So you apply loads to very specific points. You can also, within CAD, constrain or create rigid points on like this piston here. And then based off of FEA analysis, which it does for you once you've set up the problem, it will solve and show how material and how geometries will bend or even fail. So you do stress analysis as well. And well, I don't have a picture for it, but design for manufacturability. So you're designing it, your part, through the lens of how is this going to be made. And the reason this is cyclic between CAD model and analysis is you have to iterate because, you know, maybe your design has to be changed to accommodate a specific manufacturing process, or you might have to change some things because you've run a thermal analysis problem through it, and your part isn't going to withstand the environment that you expect it to see. So that's a cyclic pattern there. Once you're happy with your analysis and your CAD model or your CAD design checks all the boxes, that's when you go and create a CAD drawing, which you guys have already practiced in, I believe it was like lesson 2. You made the drawing and fully dimensioned with a series of 2-dimensional sketches, a CAD drawing. That drawing is what gets sent off to the manufacturer, and that's like the recipe or the blueprint. It's what they look at to make what you've designed. Once it's manufactured, it comes back to you, and of course, you do more analysis on it, or as long as it fits the form and function. I missed some of this stuff. At any rate, yeah, blueprints. Good. I will note, there are different types of drawings, okay? So you have drawings of specific parts. This is a bearing housing right here. And that bearing housing is one small component of a much larger system. So you have assembly drawings like this that show a bunch of different parts coming together to make a full assembly mechanism system. And then based off of that, you have individual drawings. And the manufacturer will use both of these to make your end goal. All right. So then once you receive the part back, this is just a piece of 3D printed art. I thought it looked pretty cool. You check the part, and if it meets all the criteria in the drawing, great. If it fulfills the function as well, awesome. And if it doesn't, you're going to go back and redesign it, analyze it more and redesign it. Cool. Do we have any questions on the CAD workflow?
I did have one question, Brett. Do we have the stress analysis included in this Fusion 360 program?
Unfortunately, we don't. That comes with the licensed subscription, and I believe Fusion it's still pretty reasonable for CAD software, like professional CAD software. I think it's like $500 a year for a single seat, and like Inventor costs like $3,000 a year. So it's a pretty reasonable price, but nonetheless, you do have to pay for simulation. If you're still, yeah, you guys are still seeing my screen. It says that right here with that little blue, well, it's blacked out, but that little blue circle, you'd click on that and, you know, go through the subscription process.
Mm-hmm.
Generative design is in the same boat. So we don't have access to either of those tools. All right.
Can I interrupt for a second? What is that generative design?
Generative design, that's a good question. To my understanding, it allows you to track different revisions through time of the same design. So you can say, you know, you're looking at this wheel right here. That, you know, that might be the first revision from 10 years ago, and you can kind of see how it's progressed or evolved or developed over time. That's my understanding of it. I haven't used that environment all that much, so there'd probably be a better explanation than that somewhere. We can actually, this is a good time to maybe go over this. So the scope of this class is looking specifically at the design workspace and then the drawing workspace as well, making drawings off of your design. So there are these other functions, and each of them have their own set of tools and abilities. But that is something that, you know, maybe we look at in another class. Render, it makes realistic renderings of your design. This is useful if you're marketing something, but you haven't manufactured it yet. Okay, so you want to get a nice picture of it up and out in the world. This would be what you would use. Yeah, Bill, go ahead. Oh, you're muted, Bill. Here, let me click on that.
Did that fix it?
Yeah, you're good.
Okay, good. Yeah, it's after you've created a sketch and you've decided you want to have another plane. So let's say you do another plane. You have to do the finished sketch first before you move to the next plane. I'm not quite sure about that.
You do. Yeah, as a matter of fact, you have to finish sketch before you do anything.
Okay, yeah.
But you can go back into the sketch, obviously later if
Right. But I wasn't sure that if you say say you went to another face on the same sketch, could you start drawing on that other face? I've been going to test that, but I've been kind of pressed on time, so I haven't done it. But I think you could just go, say, like from one side to another side. Would you have to do a finished sketch in between that?
You would have to either be drawing in 3D space, which I think you covered in lesson 3, or you'd have to finish the sketch and then create a new one on that other plane before you could continue, or before you could sketch on that new plane.
Okay, yeah, that sounds right then. Good, thanks.
So we're kind of covering the next part of what I wanted to cover in class, which was just to review what we've gone through so far. And right now we were going through lesson 3. So I'll finish this up. Animation. I've used this workspace just a little bit as well, but it's a really nice tool. Also used for sharing information, say even to a manufacturer. And it allows you to animate. Say you have more than one component in an assembly. It allows you to animate how those components come together and how they operate with respect to one another. So it's really nice for showing like the bigger picture on a more complex system. Manufacture, you would only really use this if you were CNC machining or physically making parts. And it allows you to create actual tool paths with specific tools to make the part that you've just designed. So we won't be covering that in this class, but it is nice to know that that's a capability. Cool. So that covered lesson 3. Lesson 1 was brief, and it was just a quick overview of CAD and some of like what the interface looks like. So you pulled up this model here and navigated through it, and some of the functions. You created a project. And I guess, would anybody have any questions specifically about this lesson? No. Lesson 2, you guys got into making 2-dimensional drawings. You started with just a really simple rectangle or square, which, as you know, and I can highlight this here. Let me just open a new, or let's see. Let me start a new sketch here in a new, Mason, what do you call that again? The colorful wheel of death. So as we've learned,
Yeah, that's the rainbow of death.
the rainbow of death. Yes,
it means that something's going on with the computer.
Yeah. So again, this is probably review for most of you, but we can make rectangles in a variety of ways. So you can do a 2-point rectangle starting from one corner and going to the next. You can do a 3-point rectangle, which defines 3 of the 4 corners. Or you can, which I don't know that we covered that in any of the lessons, but that's, I think, fairly straightforward. And you can also do a center rectangle where you just specify the center and one of the, or both of the, I guess that would be half the height and half the width. So you created a simple sketch, you defined it, you finished it, and then you extruded it into a cube. From that, you picked a face to create a new sketch on, where you could then build that part into a more complex part. So you built a trough or extrude, did an extrude cut step into the cube. We also learned how to create a two-dimensional drawing. So we opened up a new drawing document in our drawing workspace, and we created a blueprint for that cube so that we could then maybe send off to someone and have like a manufacturer be able to look at this series of two-dimensional sketches and produce exactly what you wanted it from the beginning. We covered lesson 3 already right now, and lesson 4 was kind of the bulk, I would say, of the work you guys did this week, and that's because, and it's the biggest lesson in this whole curriculum, and that's because sketching is so foundational to modeling, to CAD. So you covered everything from making different geometries, various rectangles, arcs, circles. You made your own, polygons, and then you learned how to fully define them. Fully defining a sketch is really, really important. It's critical, I would say, to your design. And the reason for that is, if you don't, you run the risk of having your model change without you maybe knowing it later on. And then it's really hard to go back and possibly fix that change, that unwanted change later on. So I'll highlight what that looks like. I'll give you guys an example pretty soon here. So we learned how to fully define on the basis of using dimensions and constraints, okay, which are found while you're in sketch mode. The constraints are found up here under the constraints tab, and there's a whole number of those up here. Many of them you'll use more often than others. So for example, I hardly use the symmetry one, but I often use like the horizontal and vertical constraint. Yes, Bill, go ahead.
Yeah, can you extrude a sketch that hasn't been fully restrained?
Yes, and that's the issue. So, or that's the risk that you can extrude any closed profile. So as long as it's fully closed, then you can extrude it. But again, the risk is when you want to go back and change something, it may not update correctly if it's not fully constrained.
Okay.
And everything about fully constraining is referred to as parametric modeling, okay? You're fully constraining, you're referencing certain dimensions based off of other dimensions so that when you go to say update a design, it updates appropriately. So what I wanted to do, because I had a few questions about this throughout the week, and I think the splines were rather challenging in terms of fully defining them as opposed to like a rectangle or something. We're going to fully define a sketch using a spline, okay? And then I'm gonna add on a few other things to turn this sketch into a vase. So there'll be some new information, but we're gonna also be reviewing and focusing on fully defining something. Do we have any questions so far that I should cover? All right, So I'm going to go over here to spline, and I'm going to do a fit point spline. If you got this far in the lessons, there's two ways to make one of these. And let me back up real quick. A spline is a fairly easy way to make a really complex curve, which is rather hard to do in CAD otherwise. So I'm going to click on this type of spline, and let me see. I can't really see. Yeah, I'm on the front part of my cube and I'm in sketch mode. Okay, so at some point to the left of the origin, and also at z = 0, I'm going to start my spline. Okay, and I'm just going to add a few curves. I'm already going to restart this. I want to go out. Okay. When I'm done, because I can make as many points along this spline as I want to. So when I'm done, I can go down and click this green check. Okay, or I can right click and click OK. I would say those are the two most straightforward ways to exit out of a sketch function. All right, and this is, I think, also what has been challenging for a lot of you is there's like 10 ways to do one simple step. And so knowing which one's the fastest or easiest or most straightforward, that can catch people up. So again, I could have clicked on this little green check mark, or you can right click, which is typically what I like to do, and click OK. All right, so we have a spline and we have these green handles on each point. Those green handles, they display or they allow you to manipulate the angle at that point and the magnitude as well. So there's an angle component and a magnitude component. So when we think of fully defining this spline in 2 dimensions, okay, we have not only 4 points that have to be fixed, we also have the associated handles, both the angle and the magnitude. All right. So if you look at a specific point, you have angle, magnitude, and the points X and Y locations. Okay. So you have 4 different things about each point on a spline. So that for us right here is 16 different points that we have to consider when we fully define this thing. So I'm going to go ahead and start doing that. Real quick, because I'm making a vase, and this will make sense in a second, I'm going to go ahead and close this sketch. Okay. This will be a good point to highlight actually what happens if you don't properly constrain a sketch. Okay. So I'm going to finish sketch here. I haven't constrained anything. We'll come back and we'll do that. I'm going to finish my sketch. Side note here, again, talking about mechanics, shift and then holding down the scroll button on your mouse allows you to get to an orthographic view or kind of maneuver to any view that you want. So again, you're holding shift and then clicking the toggle button on your mouse, or sorry, the scroll button, the center button. If you're on a laptop, I don't know what that equates to. But if you are on a laptop and you want to get to an orthographic view, something you can do is go down here to orbit, okay, on the bottom panel, and that allows you to freely orbit as well. It's the same function, it's just not as quick. It's going to stay in orbit mode. Okay, I'm not going to get out of it until I click escape. The other thing you can do, CAD gives you 10 ways to do the same thing. To manipulate the view is to come up to your view cube and click on different parts of it to get to get the right orientation or the orientation that you desire. So you can look at a single plane, you can get an orthographic view, or you can look at 2 planes like that. Okay, so I want to make a vase. In order to do that, okay, I need to take this profile and I want to revolve it 360 degrees around this axis, which happens to be the z-axis, but it's also the edge of the vase, okay? So to do that, I'm going to go up to create, and I can either click create and find revolve down here, or it's also one of the kind of the quick options at the top. So I'm going to click revolve. With each function, excuse me, which each of these functions, or the majority of them, when you click on it, you're going to get a little control panel. All right, that's going to give you a set of parameters that you have to run through in order to operate or execute that function. So we see here that the first thing that I need to select is the profile. Well, it's this sketch here. So I can click on it here, or I can go over to my browser. Another way to highlight it is to come down and click on the sketch here. It's under the sketch folder. I'm going to select the axis. So I can select the axis in a number of ways. One is I can make this edge of the sketch the defining edge that it revolves around. So I can do that. Or I can come over to my origin because I know it's on my z-axis. Click down on the origin folder, and I can find the z-axis and make that the revolve axis. So I've done that, and there's a bunch of other functions here, right? What if we only wanted to revolve at 180 degrees? Okay, or any degree around that axis. Well, I'm making a vase, so I'm going to make it 360 degrees. Okay, so here we have a really fat vase, and it's not quite a vase yet because it's not hollow. Okay, so here's where parametrics and here's where defining your sketch is really, really important. Let's say, man, this vase, I don't like the shape very much. I want it to have the same curve. All right, I want it to have the same outer curve, but I want it to be narrower. All right, so the way that I would do that is I would go into the original sketch, which again, you probably guessed it, you can do it a number of different ways. I can double click on sketch here. I can also come down here to the history, and I can double click on that sketch. You can see that it's highlighted when I'm toggling over it. Or I can even click on the revolve, right click, and click edit profile sketch. Okay, edit profile. The profile is the revolve. It's the extrude tool that you used, but you're editing the sketch that you extruded in that step. So let's go ahead and click that. All right. So like I said, I want to keep this same curve, but I want to narrow the vase itself. And because, yes, Dana, go ahead.
You just did that thing that I wanted to do so badly by clicking on the timeline down there.
I did.
I'm on a Mac, and I cannot figure out how to get that to appear on a Mac.
This here?
No, you just had that other, you just clicked more of a larger, yeah.
This here.
Yep, that one.
So I'm right clicking on a mouse. So do you have a pad?
I have
Maybe
trackpad.
Control.
Yeah.
Control.
Okay. Yeah, I don't know. I'll have to Google that, and I'll see if I find an answer for you, Dana.
Okay, thanks.
So, all right, the importance of fully defining your sketch. If I come in and I try and make this, 30, all of a sudden, you see how that changed the outer profile that I wanted to keep so bad? So I have not successfully been able to go back, adjust the overall, say, width of the vase while maintaining the outer curve that I liked or that I wanted. If instead I had defined this spline, which we'll do right now, you'll see that we can come back to it and we can change specific parts of it without compromising the rest of the sketch or the rest of the design. So we had, well, fortunately, okay, we have two fully constrained segments here. I'm going to constrain this top as well, and we're going to make it, this is using parametrics here. I'm going to make it the same as the bottom. So they're both at 60. The reason this is still blue is because we've defined where this point is horizontally in the x-axis, but we haven't defined where it's at in this axis here. So we got to do that. Let's just call that 80. Right. So see, that snaps black once it's fully defined. We've defined this point's horizontal and vertical component. We're going to just kind of go through the rest here fairly quick. Again, I mentioned that each point has 4 things that we have to consider. We have to consider the handle, which is angle and magnitude, and then the point itself, which is a horizontal and vertical dimension with respect to either the origin or something that is fully constrained. Does that make sense?
Can you repeat that?
Yeah, you can. Maybe I can highlight it here. Let's see here. Okay. I can fully, here we go. I can fully dimension this point or this segment with respect to the origin here, which is always a good way of doing something. Or
It's like history, geography. It's the,
so I can do one of 2 things to fully constrain something dimensionally. I can dimension the segment with respect to the origin, or I can dimension it with respect to something else that is fully constrained already. And which this wasn't a great example because this also happens to lie on z equals 0. But let's say it didn't. Let's say this this rigid and fully constrained segment, lied over here at like x equals -2. I could still define this segment off of that vertical line over at x equals -2, and it would become fully defined because we had a black segment over here. Did that answer your question, Chelsea?
Yeah, but the segment on the right is just to orient the model, right? It's not being used in the design at all.
This here?
What you just had, yes.
Yeah, this was just an example of how you can either define off of a black segment, a fully defined segment, or off of the origin. Yeah, it's not being used. I'm going to delete it.
Okay.
All right. Moving right along, let's make this. I'm actually going to delete that, and I'm going to go like this. So see how I can, Mickey, this is kind of getting to what you were asking. You know, it's kind of tricky, you know, which angle do we choose? And even when we get in really close, you know, it might even change to like a magnitude as opposed to an angle. We're not in an instance where I can right click and change what dimension I'm trying to define, because the only thing I can define right here is an angle. So I'll try and find one of those where we can right click and choose an option. Yeah, Mason, go ahead.
Yeah, so I can't figure out how to get that. How did you get that angle to just show up like that?
Good
That point.
Good question. Yeah, I appreciate you bringing that up, and that kind of hits a point in some of the tutorials too. Sometimes I breeze over things that that I shouldn't. So I'm hitting dimension up here, Mason. Okay. And I already have the handle highlighted, which is why this is showing magnitude. Okay, it's showing a linear dimension. What I have to do is then click on another edge, the edge that I want it to be to define an angle off of, right? So 2 intersecting line segments.
Well, I think that I'm doing that. I am doing what you're saying, but I'm not getting an angle like you're getting. I just still continue to get.
Do you have both lines blue? Are they both highlighted?
Which lines?
The 2 lines that you're hoping to define your angle off of.
No, just the one turns blue. Well, one turns blue and the other one does not turn blue.
So,
oh wait, there it goes. Hey, ha 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 ha. Okay.
that another good. I think this highlights another good point that I overlook some of these things based off of familiarity, but both lines have to be highlighted or blue.
There's something else I might say. I have a feeling that my bandwidth is causing a lot of my issues, because I think that there might be a slight delay from when I'm clicking something to when the program actually accepts that I've clicked it. And so I think maybe I'm going too quickly, perhaps, for the program. And I think that I'm doing something, but it's not actually registering. And then therefore nothing happens because anyway, okay. I'm gonna mute myself again.
I'm gonna unmute myself and say that happened to me a bunch, and I restarted like even twice or 3 times, and then things looked completely different.
Dana, thank you. Yeah, and I think Mason, that's what we did last time, right? You had some weird issues, and we restarted it, and that fixed it.
Yeah, no, that's true. That's true. But here, I mean, I'm here at work where we've got fancy internet, so I don't know what my problem could be.
Yeah. I might have to take a look at that with you, Mason.
Okay.
We'll look at your computer specs. Yeah, Robin, go ahead.
If you wanted to make the vase less wide, could you change the origin point relative to the curve and just make that part skinnier?
Yeah.
And then the rotating would go on, but it would be overall less wide.
That's correct. That would be one way to do it. Yeah. But we still run the risk, if it's an undefined sketch, of having the curve change if we don't want it to change. Does that make sense? If we want to keep the outside profile the same, we still run the risk of changing that unless it's fully defined.
Okay. And is it possible just from this sketch, could you drag the origin point closer to the squiggle, or do you have to move the curved line closer to the origin point?
Well, what I would do and what we're gonna do is we want this edge fixed on the origin, or at least I want to. That's a preference thing because I build everything off of the origin itself. To build off of anything but the origin is kind of offsetting your whole environment a little bit, which is adding unnecessary complexity, I would say. So it's good practice to start off of your origin and then build from there. I hope that answers your question.
Okay, thank you.
Yeah, you bet. Stephen, go ahead. Or Dana, do you still have a question? No. Okay, Stephen, why don't you go ahead and then I'll keep dimensioning this as you ask your question.
I'm curious how you're coming up with the angularity on a curve. Are you just kind of like eyeballing a segment and then determining that? Because, you know, a curve is a continuously changing angle. So I can't quite tell what you're doing. Are you taking like a tangent and then defining that, or how are you doing that?
Yeah, I mean, that's a good question. It's a little bit free form, and that you bring up a good point. There's free form, and then there's parametric modeling. Okay, and Fusion allows you to do both, and this is kind of a hybrid of the two. So you're creating a complex curve that isn't necessarily directly. How would you say that? It's a compound curve, so it's hard to define it, say, based off of just this angle and just this magnitude. So I'm kind of eyeballing it. I guess that's the short answer. Till I find the outer, you know, curve of the vase in this case that I prefer. So good question. I didn't really answer it very well, but did I answer it enough? Does that answer?
I was just curious if you can define the qualities of a curve. It just seems like it could be a point cloud that was fine enough to serve the purpose, but I'm not sure. So what you're going to do is you're going to find 4 points on the line, and then why, if you pull that over, does the curve stay the same?
The curve will stay the same because I'm defining all of the parameters that it's comprised of. So it is defined. It is defined by these 16 parameters in this case. The 4 points with their locations and the angles and the magnitudes of their handles. So it is some complex algorithm that, you know, I can't explain the mathematics of, but it is embedded in the program.
Oh, okay. So that's actually in the code of the program.
Yeah, absolutely. So I'm not, you know, necessarily worried about what these are, and I'm not making a very pretty sketch because all I want to do is fully define this. So we saw that this complex curve here just turned black because I've completed, you know, all the handle dimensions and on all 4 of these points, and I've dimensioned all of the points vertically and horizontally. So for example, this point is 47 in the vertical and 53 in the horizontal with respect to our origin here. Yeah, go ahead, Stephen, you have another question? And Will, you had your hand up?
That was my point, was I expected it to go black when you got it fully constrained, and it did. So
yeah,
that was it.
Nice. Stephen, go ahead.
Oh, I must still have this on. No, I'm good.
Okay. All right, you guys. So this is kind of all to say, right? The whole intention here was to make this skinnier, and we wanted the outside profile to stay the same. Now, and I think it's even worth pointing out, if I had not made this dimension a function of this here, right? I said that this dimension here equals 60 or equals D2. Then if I hadn't done that, this would shift and that point would stay the same. So that's the power in parametrics. You've related this here, you've driven this top face to this bottom dimension here. So when I go and I put in 30, Oh man, that wasn't supposed to happen. I did this at home and it worked great. Hold on. Let me go back. Oh, I made these with respect to one another. Silly. Good point. Sorry. Okay, so the issue here was I had driven these 2 points off of the axes when they should have been in relation to each other,
Oh,
so that the curve stayed the same.
oh, brother.
Okay, we're nearly there. All right. Let's hope that worked, huh?
Mine is such a mess. Mine does not look like yours, and it's also still not fully constrained.
So that's partially because this looks like a mess too. But I guess this was maybe too complex of an example. We could do this with a cube too. But the point is this outside curve has remained the same, right? Because we have fully constrained this sketch, and in this case, in a certain way. We had to define these points here with respect to each other so that that curve shifted in space. So,
Brett,
yes,
if you hadn't defined the top as a function of the bottom,
yeah,
and then you tried to move the bottom with the spline being constrained,
yep.
it couldn't, I don't know how it could move.
So that's a good question. It's because this top point, let's see, let's try it. Let's run it through those paces real quick. Let's make that a rigid 60
Yeah,
and make this 30. See, that has stayed at 60 while this has updated to 30.
but that changed the spline.
It changed the spline, right? Because, well, that is a good point.
I don't know how it did that if it was constrained.
Well, you're right. It's constrained, but it's constrained in a specific manner such that it doesn't compromise that outer profile.
Okay. Okay. Well, that was a good test. Good experiment.
Yeah. All right. Do we have any other questions about this here? If we wanted to update our vase, we'll go like that. Finish sketch. I will take it through one more function here just to complete it. And that is, I'm going to use the shell function, which I think we have used, I believe somewhere in lesson 4. I'm going to come up here to modify, okay? And one of the top selections is shell. And again, a control panel pops up, and I simply have to, in this case, select the face that I want to be open on the object. So I'll select the top face of this vase. And now it's prompting me to put a wall thickness, okay, a wall thickness of the vase. So that, let's say 2 millimeters. So if I look inside this here, we've effectively hollowed it out. We've shelled it with a 2 millimeter wall.
It's great.
And that's that. You might go in and apply, a fillet, for example, to make it prettier, so on and so forth.
What's the spine? in the inside.
This here,
Yeah, just the,
that is a residual of the sketch. The sketch is already hidden, but it's showing where the revolved start. So I don't believe that's real. It's just a rendering, I think, in the software.
Huh.
I've got a
Interesting.
question.
Is this Dana?
Yeah, it's Dana. So that when you clicked on that to do the shell, and then it says, there's a little box that says tangent chain, I think.
Yeah, let me take a look. Let's go back. I'm going to delete the fillet.
Yeah, so when I was trying to do it on the lesson 5, I could not do the shell. It wouldn't hollow it out. And then until I unclicked that box, it only then it let me pick one surface, and then it hollowed it out
Sure.
just fine. But yours is checked.
Yeah, that's it. I don't honestly know that specific component. My guess, if it's saying tangent, is that it's running tangent to each. The inside wall runs tangent to anywhere on the outside wall, but I couldn't be certain. I'd have to look at what that actually does or means.
Okay.
Yes, Robin.
When you ran the shell function and then rotated to show us that it was hollow, it looked like the bottom was white. Does that mean that the hollow feature went through the bottom as well? It wasn't gray like the rest of the vase.
Just they put in like a perspective lighting, right, in the environment, so that you can get an idea of perspective. See this shimmer right here?
Yes.
Shimmer right here. That's what you're seeing as I kind of
Oh,
toggle.
okay.
So it's just a perspective lighting in the work environment.
Okay.
And that can actually be changed too. Preferences or something. I'd have to look it up.
Okay. Thank you.
Yeah, Steven. Do you have a question? No question?
No.
All right, Dana, do you have any more questions? No. All right. I'm going to give you guys some work time. And you guys can go into your, or I'll put you in the small groups again and just keep chipping away. The whole intent here was to show you how parametrics, right? Defining, not only fully defining a sketch, but defining it in a certain way is important to going back and being able to revise that existing part and not have it change in ways that you don't want it to, which it even did for me. We kind of had to problem solve on the fly there because it wasn't defined in a particular way. Cool. So if there aren't any other questions, there isn't a whole lot of work time left, but we'll give it like 15 minutes. And then in the last few minutes, come back together as a class and kind of wrap up today. That sound good?
Okay.